Hi, in this video, let's take a look at the forward rates. So let's first recall the spot rates. The spot rates are the interest rates that you will be quoted on the spot for any given number of years that you're going to invest or save. So we have the R1, R2, R3, or how many years you have here, which is the 1 year, 2 year, and 3 year spot rates. Okay, and they will be used as your appropriate discount rates for how many years you will have for your savings. Okay, so let's take a look at this example here where we have 3 years. So I have R1, R2, and R3, which are my 1 year, 2 year, and again 3 year spot rates. Okay, so I'm just throwing random numbers here: 2%, 3%, and 5%. Okay, so that makes me pretty certain that if I have 3 years of my savings, then I'm going to get a return of 1 plus 5% to the power of 3. Yeah, so easy as that. So let's think about another scenario, which is, why don't I just save for 2 years, and then at the end of year 2 I take out my savings and then save at whatever rate year 2 provides me with for 1 year, and then I get to year 3 and I make that commitment right now. So the question is, what will be the appropriate interest rate from year 2 to year 3 if I make a commitment right now? Okay, so that future interest rate that you'll be quoted right now is basically the forward rate here. So we already have the 2-year spot rates given here at the R2, which is 3%. So we're just going to need the forward rate from year 2 to year 3. So how are we going to calculate this? So intuitively, we're both saving for 3 years. So no matter, we're just saving it from year 0 to year 3. Okay, so the beginning and the end are the same here. So if I save in another way, so basically if I taken another path here, so 2 years first, and then take it out, and then save it for 1 more year, it's still 3 years. So it shouldn't matter the way I save it. The result should be the same, all else equal, right? So without any further information, they should provide me with the same result here. Otherwise, if one method or one path gives us a higher return, then everyone should do that path, right? Or use that method of savings. So without the opportunity for arbitrage or mispricing for the rates, the path of savings should not matter. So they will always yield the same return. So with that in mind, we can calculate the forward rate from year 2 to year 3. Okay, so let's first save for 2 years, which is from year 0 to year 2. And then we take it out and save for 3 years. And that is a commitment we can make today. And that forward rate is going to be the quoted interest rate for the future, but for today. Okay, so we would have 1 plus 3% to the power of 2. So that's the first 2 years that I'll be saving. And then the commitment I have made here today, okay, from year 2 to year 3, we can call it forward from year 2 to year 3. Since it's only 1 year, we only have to the power of 1. It should yield the same result if we save from the beginning to the end. Okay, so 3 years straight. So that will give us the same result of 1 plus 5% to the power of 3. Okay, now we can work backwards to calculate this forward rate, which is the forward rate from year 2 to year 3. Okay, and then if you plug in numbers here, okay, just do the calculations, and you will have the forward rate from year 2 to year 3 to be 9.12%. Okay, so in some textbooks or in your university's lecture slides, you might come across a different notation for the forward rates. Sometimes they'll be written as 2F3 or some other notations, but that doesn't really matter. Okay, just follow the convention you're provided with and be clear about from which year to which other year. Okay, so make sure you you get these years correct, and then the notations shouldn't matter. So this is only my habit of writing the forward rates here. Okay, so with this in mind, we can also calculate other forward rates as well. So we can choose different paths here, which is why don't I just save for example, 1 year here, and then I commit to save for another 2 years. So basically, I am going to calculate the forward rate between year 1 and year 3. Okay, so how is this going to change our calculations here? So in this way, I'm going to save for 1 year, which is going to give me the 1 year spot rate, which is 2%. Okay, to the power of 1. So if you're more proficient in this, you can skip this 1 here. Okay, but from the very beginning, I always advise you to write everything in order. Okay, so 1 plus 2% to the power of 1, and then we have the forward rate from year 1 to year 3. Since that's going to be 2 years here, right? From year 1 to year 3, I will always add the power of 2, and then it should give me the same result as just saving 3 years from the beginning to the end. Okay, and this will give us the forward rate from year 1 to year 3, or the F13 here, which is going to be 6.53%. Okay, so be careful to take the square root because of this, right? So what other forward rates can we calculate in this example? That's the forward rate from year 1 to year 2. So I don't always have to save for the 3 years here. I can just save for 2 years, but for saving 2 years, I have another path for saving 2 years as well. So I can save for 1 year, and then I will commit to the forward rate from year 1 to year 2. Okay, so that basically gives us 1 plus 2, okay, 1 plus 2%. Let me just use this color to make them consistent. Okay, 1 plus 2% to the power of 1, and then 1 plus the forward rate from year 1 to year 2, also to the power of 1, should give us the same as saving for 2 years straight. Okay, so 1 plus 3% to the power of 2. Okay, and that should give us the forward rate from year 1 to year 2 as 4.01%. Okay, right, and that's how you calculate the forward rate if you're given the spot rates and you're given how many years here, right? So we can generalize this into a single formula here. So let's assume that we're going to first save for a certain years, so our S or S years here, and then we commit to save another T minus S years. So we'll be getting F from S to T years. So the power would be T minus S. Okay, and that should give us the same results of saving just T years straight. So I'll be giving our T to the power of T. Okay, so in our example here, the S here, for example, you could have S to be 2 and then T to be 3, right? That means we save for 2 years and then we commit to save for another year using the forward rate. And that's going to be settled in the future, but this rate is going to be quoted right now. Okay, so that will be T minus S, which will be 3 minus 2 in our example here, right? So that gives us 1. So T would be 3 here, right? Or you can change the numbers. If S is 1, then this is 3, then this becomes 2. This whole thing becomes 2, so which matches our second calculation here. All right, so you can memorize this formula here if you're ever asked a question on the forward rate, and this will work if you're given the appropriate discount rate or the spot rates and how many years we're considering here. Okay, so remember, the forward rate is something that we get right now, but gets settled in the future. Okay, but that doesn't necessarily mean that in S years of time, the real interest rate is going to be that forward rate. It could be the same, it could be different. It's that we're settling it right now, or we're getting quoted right now and settle it in the future. Okay, so try to differentiate between the forward rate and the actual interest rate in the future. Okay, so if this thing does not hold, then it may provide us with opportunities for arbitrage. Okay, and we'll provide you with another example in the next video, and I'll see you there.